Hi, and welcome back to Gaffy's Grinds. In a previous video, we learned about what concentration is and how to calculate concentration in two units, in moles per liter and in grams per liter. Now, I strongly suggest that if you haven't already watched that video, that you watch that one before you watch this one, because otherwise this one is going to be very difficult and confusing. So moles per liter and grams per liter, we walk through both of those calculations and how we do them. There may also be a case, though, where we have to convert from one of these to the other. So we can convert from grams per liter to moles per liter. Now think about this for a second. We're keeping the volume measurement, the volume unit, the same. We're measuring it in liters. So that's no problem. There's not much change going on there. What does change is we're going from units of grams as a measurement of the solute to units of moles as a measurement of the solute. And this definitely is not something that's new to us. We've done this loads and loads of times before. From grams to moles, we know we're going to think about the MR, or the molar mass of the substance, to go from grams to moles. It's the same kind of idea here. So let's jump into a problem. It's probably the best place to start. 1 second. So here is a problem for us to work on. Now let's have I'm going to get you guys, I'm just going to get you guys to stop. I'm going to pause and I'm going to let you have a read of this question carefully. Okay. All right, what I'm hoping, the first thing you're noticing is that our answer is going to be in moles per liter, because it says calculate the concentration in moles per liter. Now, we don't currently have moles. We have a number of grams per a certain amount of liters, so grams per volume. So I always think that it helps if you start by planning out what exactly you have to do before you start. So I'm going to model this for you now, what I'm thinking here. I'm thinking that I've got a grams in a certain amount of liters. So I want to go from grams per liter to moles per liter. So that's what I have to do. There's only one step here, going from grams per liter to moles per liter. So one conversion is all I really have to do here. I've already got everything in liters. So I've got 2 liters here, and I need to end up in liters. So this is good. All right. So the first thing we're going to do is write down what we know. That's why I always say write down what you know and write down where you're going. All right. So the first thing to note is that I currently have 3.65 grams and the substance is HCl. So I'm going to write that in here. I've got 3.65 grams of HCl per in 2 liters of solution. Now, I know I'm going to have to convert from grams per liter to moles per liter. So I'm going to need a conversion factor. Conversion factors are fractions. Mess of this now. Conversion factors are fractions, so I'm multiplying it by a fraction. I'm going to think very carefully about the units in a second, and I need to think about what my answer is going to be. My answer has got to be here, because this is what it's telling me. I've got to end up with a number of moles per liter. Okay. Now, so the next thing I need to do is think about how do I convert from grams of HCl to moles of HCl. Well, there should be a moles of HCl per liter in the end. All right. All right, so let's think for a second about the units I currently have. I currently have liters in the denominator, and I need liters in the denominator over here. So that's good. I don't have to do anything with the denominator unit. But I currently have grams of HCl in the numerator. Sorry, I should use a different color. I'm going to change from blue. I currently have grams of HCl in the numerator, whereas I need moles of HCl in the denominator. Thinking then carefully about my units. What do I have to do with my units in the conversion factor here? Well, I need to make sure that grams of HCl is in the denominator. The reason for this is, as we've seen loads of times before with unit analysis, I can then cross those out. My grams of HCl are gone. And because I need mole of HCl here, then I'm going to put that in the numerator, mole of HCl. Like that. Okay, the next thing I need to think about is how many grams of HCl do I have for every mole of HCl? So for 1 mole of HCl, how many grams is it? Well, here I need to go to my periodic table and look up the masses of these atoms. So I've got 1 for my H plus 35.5 for my Cl. So 1 plus 35.5 gives me 36.5. I'm going to put that into my calculator and do the sum now. So I'm doing that now. I'm getting 0.05 mole of HCl for every 1 liter. This can also be expressed like this, 0.05 mole slash L or 0.05 capital M for molar. So that's how you go between grams per liter to moles per liter. Again, similar idea, just using unit analysis. Make sure that the units you're left with, like here, mole per liter over liter, sorry, moles of HCl over liters is what gives us our answer, moles per liter over liters. Okay. Here is the second problem. I'm going to get you guys to pause this and have a look at it carefully before we start. Okay, so what I'd like you to do is pause the video and write down the plan of what we have to do. Like I did over here in red, up here, I want you to do the same with this one. Pause the video and do that now. Again, hopefully what you did is you said, okay, well, we're given a number of grams and we know it's in 1 liter. So we're going from grams per liter again to moles per liter. Again, always a good idea to plan it out. All right, so the next thing we're going to do is I am going to set up the unit analysis for you and you guys can go ahead and finish it. All right. In the beginning, we have a certain amount of grams and the substance is NaOH. We have grams of NaOH in a certain amount of liters. Times by, we're going to set up a conversion factor. It has to be equal to a certain number of moles per liter in the answer. What I would like you to do is I would like to pause the video and try and do the units here and here. What units do we need here and here? Nothing else, just do the units. Okay, so you should only be playing if you've written in the units in the conversion factor. In the conversion factor, we don't need to cancel liters. Why is that? Again, maybe I should write it out in a different way. I should write moles of NaOH per number of liters. Okay. So here you see we've got liters in the denominator and we need liters in the denominator over here. So that's good. So I'm not going to touch liters from here on out. What I do need to touch is grams because grams is not in our answer unit over here. So to cancel grams, it should be in the denominator here, grams of NaOH. Cancel there, cancel there. What has to be in the numerator? Well, that's the last unit that I actually need here. And that's moles of NaOH. So I'm going to put in, sorry, not red. Mole of NaOH here. Right, now that we have all the units done, this is what we should always do first. What we need to do now is we need to put in all the numbers. So pause the video and do that now. Okay, all right, so I'm going to work along with you now. We started with 160 grams of NaOH. That's what it says here, 164 grams, and it was in 1 liter, so per 1 liter. Good. Now, the next thing is how many grams are there for every mole? So for 1 mole of NaOH, how many grams is that? Well, go to your periodic table again. You should see that the sodium atom has a mass of 23, the oxygen atom has a mass of 16, and the hydrogen atom has a mass of 1. If you added them all up, you would get 40. So if you put 40 there, that's fine too. Otherwise, you can just put it in and put them in the calculator like that and still get the right answer. Okay. All right, so I'm going to go ahead and do this sum now. You can pause the video and have a go at yourself if you haven't done it already. Okay, and I am just going to do that now. Give me 1 second. And the answer that I'm getting is 4 moles for every 1 liter. Again, we can rewrite this as 4 mole per liter or 4 molar NaOH. So it's 4 molar NaOH. Because this isn't the easiest thing in the world, we're going to do a couple more examples because I think you really need to see quite a few of these before I set you off to practice by yourself. All right, so this one, again, what we're going to do is we are going to plan it out, and I'm going to help you with the unit analysis, and you're going to do the numbers yourself. Okay, so let's plan it out. Pause the video and write down what's the plan here in red. Okay, so again, hopefully you did this. We're given grams per liter, 80 grams per liter, and we're going moles per liter. Pretty straightforward. Now, that might seem like a waste of time now to write down that plan, but the reason why I'm getting into the habit of that is because as the problems get harder and more complex, and there's more steps, and then you'll see the value of actually getting in the habit of planning. Okay, so we're going to begin by writing down that we are starting with 80 grams per liter. Per 1 liter. We're going to have a conversion factor, and we're going to give our answer in moles per liter, and it's NaOH again. NaOH, and the substance here is NaOH. All right, so I'm going to get you to again write down the units in the conversion factor here and here. Don't do anything else for now. Just do that, please. Pause the video, do that. Okay, so again, hopefully what we're looking at here is we're leaving the units alone, or sorry, we're leaving liters alone. We don't need to cancel them, but what we do need is we need to go from grams of NaOH in the denominator here to moles of NaOH. Right, so for every 1 mole, we have, again, let's just use our example from the previous one was 40, remember? We're going to take a little shortcut because we've done that already, and then we're going to go ahead and do the sum. Pause the video, finish it off. Okay, what I'm getting here is 2 moles per 1 liter, or 2 molar NaOH. Here is another one. This time I'm going to get you to write out the plan again. Pause the video and do that now. Okay, again, we're going from grams per liter to moles per liter. All right, I'm not going to help you with any more of this. What I want you to do is I want you to pause the video, do the whole sum out, write down what you have, do the unit analysis first. Remember, that's why we keep practicing the unit analysis first. Can't go wrong then, and then finish it off. Okay, right, so let's have a look then at how this should be. So you should have it all done now. You should only be watching if you've had a go at the whole lot. All right, so we have 53 grams, and it's Na2CO3 per 1 liter. What we had, 53 grams per liter. Now, I need to multiply that by a conversion factor, which we won't think about the units just yet. Think about the units in the answer to give me moles of Na2CO3 per liter. Okay. All right. Now thinking about the units, I'm leaving the liters alone because liters need to be my answer, and I'm getting rid of the grams. Grams of Na2CO3. Cancel those out like that and like that. Good. The grams is gone. And we have moles on top of Na2CO3. So the answer is, for every 1 mole, how many grams of Na2CO3 do we have? Okay. So this one is a little bit more complex. We've got 23 times 2 for the 2 sodiums. We've got carbon, so plus carbon is 12, plus oxygen is 3 times 16. Okay, so I'm going to go ahead and I'm going to do this whole sum now. You should have done the same if you haven't done it already. 53 times 5 over 23 times 2. Okay, so the answer that I'm getting here when I do all of that out is 0.5. 0.5 moles of Na2CO3 per 1 liter, or 0.5 molar Na2CO3. This is a solution with 0.5 moles in every liter. So it doesn't matter if you had 10 liters of it, you would have 0.5 moles for every one of those liters. For each liter, there will be 0.5 moles. That's how this works. Okay, so that was from going from grams per liter to moles per liter. All of those problems were the same type. All right, so let's now have a look at question 11 here. Okay, so I want to pause the video and have a go at all the questions in question 11. Okay, so hopefully you have had a go at those and those were all okay. I just want to look at another possible scenario that I didn't really take an example of that much. Let's say we had a 0.73 molar solution of sodium hydroxide, NaOH, expressed in grams per liter. Okay, how is this different? I want to pause the video and write down the plan. What's the conversion here? What are we doing in terms of the plan? Pause the video, write it down. Well, I'm hoping that you can see that we're going from sorry, no, not the numbers. The numbers have nothing to do with it. We're going from molar, which is moles per liter. So it's very important that we remember that molar means moles per liter. And from that, we're going to grams per liter. So we're walking the opposite way this time. All right, so let's go about, let's do this one. So let's write down what we have. We have 0.73 moles. And the substance is NaOH for every 1 liter. And we're going to times by a conversion factor and make sure then that our answer is in a number of grams of NaOH per liter. That's what it asks us here. Grams per liter should be the answer. All right, so going back to my conversion factor, what do I need to think about? Well, I don't need to think about liters because liters needs to be in the answer, so that's fine. But I do need to get rid of the moles of NaOH. So to get rid of them, I'm going to put them in the denominator of the conversion factor. Moles of NaOH needs to be down here. Those can then cancel with those moles like that. And then in the numerator, I'm going to put grams of NaOH. And again, once we know the relationship between moles of the substance and grams of the substance, like this, for every 1 mole, there are how many grams? Well, there is 23 grams for the sodium, there is 16 grams for the oxygen, and there is 1 gram for the hydrogen. So again, altogether, that's 40. We've already used that example before. And then we're just going to go ahead and finish this up. So 0.73 times by, so over 1, sorry, times by 40 over 1. And the answer I'm getting here is I'm getting 29.2 grams for every liter. So now I've got my answer in grams per liter. So 29.2 grams / L, gram per liter. All right, so hopefully you can see it's a very similar idea, except we're going the opposite direction. We're starting with moles, going to go into grams. All right. I don't think you need me to explain any more of those or to practice another one. I'm confident that you guys would know how to do that now. So let's look at question 12 now. Question 12 asks you to convert the concentrations to either grams per liter or moles per liter. So of course, what you have to do depends on what you're starting with. So for example, in the first one, we're starting with grams per liter, so we'll be going to moles per liter. In the second one, we're starting with moles per liter, so we'll be going to grams per liter, so on. So you pause the video and work through question 12, A, B, C, and D. Okay, hopefully those are pretty much making sense. Your unit analysis should make sure you're confident about the answers, but we will go through them in the when we're back in class. The last thing then is some challenge questions. So these are really gonna stretch you a little bit. What I want you to do is I want you to work your way through question 13 and 14. As you can see here, the first part of each of these questions, I have helped you or kind of done an example for you. So I want you to work your way through them, figure them out, and then complete the rest of them. They're higher level problems, but they still do get asked on the exam. So I do want you to try and work out how those would be done. Yeah, I think you should be okay with those. So yeah, that's it, guys. We'll see you in the next lesson. If you found this video useful, please do leave a like. Again, it just helps more students out there who aren't in our school, who might be struggling to find them, and help more students. That's what these are for. So thanks, guys. We'll see you in the next one.